I stood inside a ship the system had already written off, measuring water where engines once turned. My superiors wanted reports, not doubts, and the orders left no room for what I could see forming. Every compromise I approved stayed with the steel, waiting to be tested under fire. When we finally went back to sea, the weight of those decisions did not lift. December 1941, Pearl Harbor, territory of Hawaii. The United States Pacific Fleet lay concentrated inside a shallow, constricted anchorage, its battleships moored in neat rows along Ford Island. For decades, American naval planning in the Pacific had revolved around these ships. They were slow by modern standards, heavily armored, armed with large-caliber guns, and designed for a style of warfare that emphasized decisive surface engagements. To Japanese naval planners, many of these vessels already belonged to another era. In the years leading up to the Pacific War, officers of the Imperial Japanese Navy studied American ship lists with careful attention. They knew the names and silhouettes of the U.S. battleships well: Arizona, Oklahoma, West Virginia, California, Tennessee, Maryland, Nevada, Pennsylvania. Most of them had been launched during or shortly after the First World War. Their maximum speeds lagged behind newer cruisers and carriers. Their machinery reflected earlier design philosophies. In Japanese assessments, these ships were often described as old-type battleships, suitable for shore bombardment or secondary roles, but not decisive instruments in a fast-moving naval conflict. Japanese naval doctrine placed increasing emphasis on carrier aviation and night torpedo attacks by cruisers and destroyers. In that framework, American battleships were expected to be neutralized early, either by air attack or by attrition as they crossed the Pacific. The surprise attack on Pearl Harbor was intended to accelerate that process. When Japanese aircraft struck on the morning of 7 December 1941, the battleships were primary targets. By the end of that day, the harbor was filled with smoke, oil, and wreckage. Arizona was destroyed by an internal explosion and sank where she lay. Oklahoma capsized. West Virginia and California settled into the mud. Nevada, attempting to escape the harbor, was heavily damaged and run aground. Tennessee and Maryland survived but bore scars from bombs and fragments. From a distance, the scene appeared to confirm Japanese expectations. The old battleships had been smashed in place. The American battle line, as a fighting force, seemed finished. In the days that followed, Japanese commanders spoke confidently about the results. Reports emphasized the destruction of battleships and the crippling of American naval power in the Pacific. Some assessments suggested that even if the United States attempted to repair its damaged ships, the effort would take years. The shallow harbor, the extent of flooding, and the age of the vessels themselves were all cited as limiting factors. To many in Tokyo and at fleet headquarters, the battleships at Pearl Harbor were effectively written off. On the American side, the situation appeared grim, but was not yet fully understood. While senior commanders assessed losses and planned immediate defensive measures, hundreds of officers and enlisted men reported for routine duties amid the wreckage. Salvage and repair work began almost at once, not as part of a grand strategy, but because damaged ships blocked berths, channels, and facilities that were still needed. Among those officers was a naval engineer assigned to the battleship West Virginia. His responsibilities before the attack had been routine, overseeing machinery maintenance, monitoring fuel systems, and ensuring that daily logs were completed accurately. On the morning of 7 December, he had survived the attack by chance, escaping through smoke-filled compartments as the ship took on water. In the weeks afterward, he returned daily to the hulk that had once been his ship. West Virginia rested on an even keel, her decks just above the waterline, her superstructure scarred and blackened. She had taken multiple torpedo hits along her port side. The counterflooding that prevented her from capsizing had saved lives, but left the ship deeply flooded. For many observers, she looked beyond recovery. Yet the engineers' work did not involve speculation about the future. Each day began with inspection reports, measurements of flooding levels, and coordination with divers who worked in darkness and debris. The early salvage effort was cautious and methodical. Divers sealed holes, removed debris, and searched compartments for remains of the crew. Pumps were installed incrementally. Temporary patches were fitted where possible. Progress was slow, measured in inches of water lowered rather than dramatic breakthroughs. The engineer noted changes in the ship's condition in technical language, reduced seepage here, stabilized bulkhead there. There was no certainty that the ship would ever return to service, but there was also no assumption that she would not. Similar scenes played out across the harbor. On California, salvage crews struggled with corrosion and extensive flooding. On Nevada, damage control teams assessed structural integrity after bomb hits and fires. Tennessee, though less severely damaged, required extensive repairs to her hull and systems. Each ship presented unique problems, but the underlying approach was the same: restore watertight integrity, reestablish basic systems, and determine whether full repair was feasible. These efforts unfolded against a backdrop of strategic uncertainty. The United States Navy had lost its battleship concentration in the Pacific, and its carrier force was limited. Japanese advances across Southeast Asia and the Western Pacific accelerated in early 1942. There was little public discussion of rebuilding the battleships as combat units. Official statements focused on immediate defense and on the growing importance of aircraft carriers. Within the engineering and salvage community, however, assessments were more cautious than dismissive. The ships were old, but they were not fragile. Their hulls had been designed to absorb punishment. Their internal subdivision, though imperfect, provided options for controlled flooding and repair. The shallow depth of Pearl Harbor, initially seen as a liability, meant that sunken ships had not plunged beyond reach. The engineer on West Virginia became aware of these considerations not through policy briefings, but through daily problem solving. Each repair raised questions that extended beyond the immediate task. Could electrical systems be fully replaced? Would boilers and turbines survive prolonged immersion? Could the ship's armor and magazines be certified as safe? Answers came gradually, informed by inspections and tests rather than assumptions. At the same time, limitations became apparent. Repair yards were stretched thin. Materials and skilled labor were in high demand. The Pacific Fleet required ships urgently, yet the scale of damage demanded patience. Some components could not be replaced quickly. Others required redesign rather than simple restoration. The engineer noted delays in receiving parts and the need to improvise solutions that met minimum safety standards. These constraints fed into a broader operational problem. The United States Navy faced a fast-moving opponent that emphasized speed, reach, and air power. Even if the battleships could be repaired, there was uncertainty about their role in future operations. Their pre-war configurations reflected a different set of assumptions. Anti-aircraft defenses were limited. Fire control systems lagged behind emerging technologies. Without significant modification, returning these ships to service risked repeating earlier vulnerabilities. By early 1942, salvage work continued steadily, but expectations remained guarded. Some ships showed promising signs of recovery, others revealed hidden damage that complicated planning. The engineers' reports remained technical and restrained, avoiding predictions. Yet the very act of sustained repair work challenged the idea that the battleships were finished. From the Japanese perspective, these developments went largely unnoticed. Intelligence focused on American carrier movements and industrial output. The damaged battleships at Pearl Harbor were still considered neutralized, either permanently or for the duration of the war's critical early phase. Japanese commanders remained confident that even if the United States restored some of these vessels, they would not alter the balance of power in decisive engagements. As months passed, the gap between assumption and reality widened quietly. In the harbor, water levels dropped inside once flooded compartments. Structural surveys produced cautiously optimistic findings. Plans for more extensive modernization began to circulate within naval bureaus, not as bold declarations, but as practical responses to emerging needs. For the engineer on West Virginia, the workday ended much as it began, with logs completed, measurements recorded, and instructions passed to the next shift. The ship remained immobile, silent, and incomplete. Yet it was no longer simply a wreck. It was a complex system in transition, neither fully lost nor fully restored. The situation stood at an uncertain midpoint. The battleships were damaged, their future roles undefined. salvage, and repair had revealed both possibilities and limits. Strategic doctrine had not yet adjusted to accommodate them, and Japanese assessment still rested on pre-war assumptions. The operational question remained unresolved, whether these old ships, once dismissed, could be adapted to meet the demands of a new kind of naval war. By mid-1942, the operational environment of the Pacific War had shifted sharply. Japanese forces had completed rapid advances across Southeast Asia and the Western Pacific, establishing defensive perimeters that stretched from the Aleutians to the Solomon Islands. The Imperial Japanese Navy had achieved many of its early objectives, but it now faced a different problem: sustaining control across vast distances while preparing for a long conflict against an opponent whose industrial capacity was only beginning to mobilize. Within this evolving context, American naval repair efforts continued largely out of public view. At Pearl Harbor, the salvage of damaged battleships moved from emergency stabilization toward long-term restoration. The distinction mattered. Emergency work kept the harbor functional. Restoration work implied an intention to return ships to combat. That intention, however, remained uneven and contested within the U.S. Navy. Senior planners increasingly emphasized aircraft carriers as the primary instruments of offensive power. The battles at Coral Sea and Midway reinforced this view. In both engagements, battleships played no decisive role. Some officers concluded that investing scarce resources in aging battleships was a questionable use of time and material. Others argued that the Pacific was too large and future operations too uncertain to dismiss heavily armored gun platforms outright. These debates filtered down unevenly to the engineers and crews working on the damaged ships. On West Virginia, the engineering officer observed a subtle change in the tone of directives arriving from higher command. Requests for preliminary repair assessments became more detailed. Questions shifted from whether the ship could be stabilized to how long it would take to restore propulsion, power generation, and habitability. These were not guarantees of recommissioning, but they suggested that dismissal was no longer automatic. Progress, however, was neither smooth nor linear. As water was pumped out of deeper compartments, new problems emerged. Electrical systems had suffered extensive corrosion. Insulation materials had deteriorated beyond reuse. Machinery spaces revealed damage that had been concealed by flooding. Each discovery forced revisions to schedules and cost estimates. The ship's age compounded the difficulty. Replacement parts were not always interchangeable with newer designs, requiring custom fabrication or adaptation. Similar issues affected other battleships. California's salvage was slowed by structural distortion and prolonged immersion. Nevada required extensive hull repairs before any modernization could begin. Pennsylvania, though less damaged, faced limitations imposed by her dry dock availability and competing repair priorities. The cumulative effect was a sense of constant delay, even as measurable progress continued. From an operational standpoint, these delays had consequences. American surface forces in the Pacific were limited in number and capability. Cruiser and destroyer losses mounted in night actions around Guadalcanal. Carrier task forces were stretched thin, rotating between combat operations and urgent repairs. In this environment, the absence of battleships as active participants became more noticeable. Yet doctrinal resistance persisted. Pre-war expectations of decisive battleship engagements no longer aligned with recent combat experience. When battleships were discussed, it was often in secondary roles: escort, shore bombardment, or anti-aircraft defense for carriers. The idea that they could return as primary combatants seemed increasingly remote to some planners. Japanese commanders continued to view the American battleship force through this lens. Intelligence estimates acknowledged repair activity at Pearl Harbor but downplayed its significance. The prevailing assumption was that any restored battleships would be slow, vulnerable, and technologically inferior to newer Japanese units. The emphasis remained on attrition of American carriers, not preparation for renewed battleship encounters. This confidence influenced Japanese operational planning in subtle ways. Defensive perimeters were designed with the expectation that American advances would rely heavily on carriers and amphibious forces. Shore-based air power and submarines were prioritized to counter these threats. Little attention was given to the possibility of sustained battleship gunfire supporting landings or engaging surface forces under modernized conditions. Meanwhile, within American repair yards, modernization plans began to take clearer shape. For West Virginia, proposals included the removal of outdated superstructure elements, installation of improved anti-aircraft batteries, and upgrades to fire control systems. These changes were not minor. They required structural modification, new training pipelines, and integration of equipment that had not existed when the ship was first commissioned. The engineer became involved in these discussions as technical input was requested. His assessments focused on practical constraints: weight distribution, power supply, crew accommodation. Anti-aircraft guns demanded electrical power and ammunition storage. Radar systems required space, cooling, and trained operators. Each addition affected stability and internal layout. Modernization, he recognized, was not simply repair by another name. It was transformation layered onto an old framework. The pace of work remained uneven. Some systems advanced quickly once funding and authorization were secured. Others stalled due to shortages or competing priorities. The engineer noted that progress often depended less on technical difficulty than on administrative decisions made far from the ship itself. Approval chains lengthened timelines. Changes in strategic emphasis altered priorities without warning. Despite these frustrations, evidence accumulated that the ships could meet new standards. Test results from repaired boilers were encouraging. Structural surveys showed that armor and hull integrity remained sound. When portions of electrical systems were re-energized, they performed within acceptable limits. These findings challenged earlier assumptions that age alone rendered the ships obsolete. As 1942 turned into 1943, the contrast between perception and reality grew sharper. Publicly, the battleships remained absent from major operations. Privately, their return to service was increasingly treated as a matter of timing rather than possibility. Training plans were drafted for future crews. Ammunition stocks were allocated. Dockyard schedules projected completion dates that, while still tentative, extended beyond mere stabilization. Japanese intelligence failed to adjust fully to these developments. Reports noted repair activity but continued to classify the ships as low-priority threats. The focus remained on American industrial output of new carriers and escort vessels. The idea that ships damaged at Pearl Harbor might return with significantly enhanced capabilities did not feature prominently in assessments. This misalignment was not the result of negligence, but of doctrinal continuity. Japanese naval thought had long emphasized the neutralization of enemy battleships before decisive engagements. Pearl Harbor appeared to have achieved that objective. Revising that conclusion would have required acknowledging that initial success had been incomplete, an admission with implications for planning and morale. Within the American Navy, uncertainty persisted, but confidence grew incrementally. The engineer observed that morale among salvage and repair crews improved as milestones were reached. Compartments once flooded were now dry. Machinery that had seemed ruined responded to careful restoration. The ship, though still silent, no longer felt inert. Yet limitations remained. Even with modernization, battleships would not regain the central strategic role envisioned before the war. Their speed would always lag behind carriers. Their operational use would depend on air cover and coordination with other forces. These realities tempered expectations and shaped planning. The operational problem thus evolved rather than resolved. Battleships were neither discarded relics nor decisive solutions. They occupied an ambiguous position within a rapidly changing naval war. Their future effectiveness depended on integration, timing, and the willingness of commanders to adapt doctrine to new capabilities. As repair and modernization continued, the question shifted from whether the ships could return to service to how they would be used once they did. That question remained open, influenced by ongoing combat, shifting priorities, and assumptions held by both sides. The gap between Japanese expectations and American capabilities widened quietly, without public declaration or dramatic announcement. It unfolded through schedules, engineering reports, and incremental decisions that, taken together, suggested a reevaluation was underway. By early 1943, the Pacific War had entered a new phase. The initial Japanese perimeter had been breached in several places. most notably in the Solomon Islands. The fighting around Guadalcanal had exposed weaknesses in Japanese logistics and command coordination, while also highlighting limitations in American surface forces. Night engagements had been costly, and cruiser losses underscored the difficulty of contested waters without sufficient heavy support. It was within this environment that the role of battleships was reconsidered more concretely, not as the centerpiece of fleet actions, but as tools suited to specific operational needs that had become increasingly apparent. Shore bombardment, anti-aircraft defense, and surface deterrence were no longer theoretical roles. They were immediate requirements driven by hard experience. For the engineering officer attached to West Virginia, this shift was reflected in changes to daily work priorities. Modernization plans, once tentative, were now treated as directives. The ship's reconstruction moved beyond restoring pre-war condition. Entire sections of the superstructure were removed to reduce top weight and improve firing arcs for new anti-aircraft weapons. Obsolete secondary batteries were eliminated in favor of dual-purpose guns capable of engaging both air and surface targets. These decisions were not driven by nostalgia for battleship warfare. They were responses to observed failures. Japanese air attacks had demonstrated the inadequacy of older anti-aircraft layouts. The increasing density and coordination of enemy aircraft required layered defenses, radar-directed fire, and rapid communication between sensors and guns. West Virginia's original design did not accommodate these systems easily. The engineer was tasked with evaluating power generation capacity to support additional radar arrays and fire control equipment. Early calculations revealed margins that were narrow but workable. Boilers and generators, once thought marginal due to age, performed reliably after overhaul. This reliability surprised some planners, but reinforced a growing belief that structural age did not equate to functional incapacity. Similar transformations were underway on other surviving battleships. Tennessee and California underwent extensive rebuilds, emerging with radically altered silhouettes. Their bridge structures were enlarged to house new command spaces. Radar masts rose where rangefinders once dominated. Armor protection remained largely unchanged, but internal arrangements were reconfigured to improve damage control and survivability against air attack. These changes required more than technical adjustments. They demanded a shift in mindset among officers who would command and crew these ships. Training programs were revised accordingly. Crews were instructed not only in gunnery and seamanship, but in radar interpretation, coordinated anti-aircraft fire, and integration with carrier task forces. The battleship was no longer a self-contained unit designed to fight peers in line-of-battle engagements. It was becoming a component within a broader, more complex system. The turning point in perception did not arrive with a single event or announcement. It emerged gradually as commanders confronted operational realities. During amphibious operations in the Central Pacific, preliminary bombardments proved essential. Aircraft alone could not neutralize all shore defenses, particularly hardened positions. Battleships, with their heavy guns and endurance, filled a gap that no other platform could. This realization carried risks. Committing battleships closer to enemy-held shores exposed them to submarines, mines, and air attack. The memory of Pearl Harbor lingered. Some officers remained wary of placing large, slow targets in contested waters. Yet operational necessity increasingly outweighed doctrinal caution. For the engineer, risk became personal when timelines accelerated. West Virginia's projected completion date was moved forward to meet anticipated operational demands. Compressed schedules increased pressure on repair crews. Testing phases were shortened. Decisions that would once have been deferred were now made under constraints of time rather than ideal conditions. One such decision involved the acceptance of partial system readiness. Certain non-critical spaces were left incomplete to prioritize combat essential functions. Habitability improvements were postponed. Redundancies were reduced where acceptable. These compromises were documented, acknowledged, and accepted by higher command. The ship would not be perfect, but it would be functional. As West Virginia prepared for sea trials, the engineer observed a change in how the ship was discussed in official correspondence. Language shifted from conditional phrasing to operational planning terms. She was assigned to future task groups, not hypothetically, but as part of concrete schedules. Ammunition allotments were confirmed, crew assignments finalized. Japanese intelligence assessments did not reflect this shift. Reports continued to emphasize American carrier strength and industrial production. Battleships were mentioned primarily in defensive or auxiliary contexts. The possibility that rebuilt Pearl Harbor battleships might return with enhanced anti-aircraft capability and improved coordination was not prominently addressed. This disconnect extended to Japanese tactical planning. Defensive preparations often assumed that American shore bombardment would be limited in duration or intensity. The expectation was that air power would remain the primary threat. Where battleships were considered, they were treated as predictable and manageable targets, not as flexible assets adapted to new roles. By mid-1943, West Virginia conducted her sea trials. The engineer monitored performance data closely. Propulsion systems met expectations. Electrical loads remained within calculated limits, even with radar and fire control systems active. Anti-aircraft drills demonstrated coordination that would have been impossible under the ship's original configuration. The trials did not suggest invulnerability. Speed remained limited. Maneuverability lagged behind newer vessels. Vulnerabilities to torpedoes and concentrated air attack persisted, yet the ship was no longer an outdated relic. She had been reshaped to address specific operational demands. The personal dimension of this transformation was not lost on those involved. Many crew members had survived the attack on Pearl Harbor. Their return to sea aboard the same ship carried emotional weight, though it was rarely expressed openly. Professional focus remained on procedures, drills, and readiness. The ship's history was acknowledged, but did not dominate planning. The broader implication became clear within American naval circles, if not publicly articulated. The battleships damaged at Pearl Harbor had not simply been repaired, they had been repurposed. Their continued existence challenged earlier assumptions, both American and Japanese, about obsolescence and adaptability. As West Virginia prepared to rejoin active operations, her presence raised questions that extended beyond a single ship. How would these rebuilt battleships perform under combat conditions? Would their modernization justify the resources invested? And how would Japanese commanders respond if confronted with vessels they believed had been neutralized years earlier? Those questions remained unanswered as the ship awaited deployment orders, her systems tested, her crew trained, and her role defined not by past expectations, but by emerging necessity. By late 1943, the strategic tempo of the Pacific War accelerated. American forces advanced across the Central Pacific through a sequence of amphibious operations designed to bypass strongpoints and seize positions that could support airfields and logistics hubs. These operations demanded sustained naval gunfire support, extended air defense coverage, and surface forces capable of remaining on station for long periods. It was under these conditions that the rebuilt battleships were finally committed in meaningful numbers. West Virginia, along with other Pearl Harbor survivors, joined task groups assigned to amphibious assaults rather than carrier strike missions. Their employment reflected a careful balance between utility and risk. They were kept under air cover when possible, screened by destroyers, and integrated into layered defensive formations. For West Virginia's crew and engineering staff, the transition from repair yard to combat zone exposed the consequences of earlier decisions. Systems that had been accepted as sufficient rather than optimal were now tested under operational stress. Power distribution loads fluctuated during sustained anti-aircraft alerts. Cooling systems operated near capacity in tropical conditions. Maintenance crews worked continuously to keep modified equipment functioning within designed limits. The engineer found that modernization had introduced new vulnerabilities alongside improvements. Radar arrays required constant calibration. Fire control systems depended on uninterrupted electrical supply. Failures that would once have been isolated now risked cascading effects across interconnected systems. The ship's original design had not anticipated this degree of integration. Operational demands intensified during shore bombardments. West Virginia's main guns delivered prolonged fire against coastal defenses, often at close range. Recoil stresses and thermal loads exceeded peacetime expectations. Engineering logs recorded accelerated wear on mounts and auxiliary systems. These issues did not halt operations, but they accumulated, creating a backlog of deferred maintenance that concerned technical officers. At the command level, tensions emerged between operational urgency and material preservation. Amphibious commanders requested extended bombardment to suppress enemy positions. Fleet commanders weighed these requests against the risk of mechanical failure or enemy counteraction. Battleships were valuable assets, but they were not easily replaced. Decisions about their employment reflected competing priorities rather than clear doctrine. Japanese resistance during these operations varied. In some cases, shore defenses were reduced effectively by naval gunfire. In others, fortifications proved more resilient than anticipated. Japanese air attacks against invasion fleets persisted, though increasingly constrained by fuel shortages and declining pilot quality. When attacks did occur, the rebuilt battleships' enhanced anti-aircraft batteries contributed significantly to fleet defense. These engagements forced Japanese commanders to confront an uncomfortable reality. American battleships were present, active, and operating with a level of coordination and defensive capability that differed markedly from pre-war expectations. Reports from the field noted dense anti-aircraft fire and sustained bombardment that exceeded earlier assumptions about battleship vulnerability and effectiveness. Yet, institutional inertia slowed response. Japanese naval doctrine, shaped by early successes and resource limitations, struggled to adapt. Emphasis remained on decisive engagements involving carriers or submarines. Countermeasures against battleship-supported amphibious operations were often improvised rather than systematically developed. Within the American Navy, the battleship's performance prompted reassessment. Their contribution to amphibious success was acknowledged, but concerns persisted about exposure and cost. Losses among smaller vessels underscored the dangers of contested littoral operations. Battleships absorbed damage that might have crippled lighter ships, but they were not immune. Near misses, splinter damage, and occasional bomb hits reminded commanders of lingering vulnerabilities. For the engineer, these realities translated into increased scrutiny. After-action reports demanded detailed explanations of system performance under combat conditions. Failures that might once have been attributed to age were now examined as potential design or integration flaws. Accountability tightened as the ships proved their relevance. Pushback emerged in more subtle forms. Some senior officers questioned whether the extensive resources devoted to battleship modernization would have been better invested elsewhere. Others argued that the ship's demonstrated utility justified the effort, even if their role remained specialized. These debates unfolded within planning documents and staff discussions rather than public forums. West Virginia's operational record accumulated steadily. She supported multiple landings, provided air defense, and operated within carrier task groups when required. Each mission added data points to an evolving assessment of battleship utility in modern naval warfare. The ship was no longer an abstract concept or a salvaged relic. She was a working element within active operations, subject to the same risks and constraints as any combat unit. Japanese commanders, confronted with mounting losses and shrinking options, adjusted tactics incrementally. Increased emphasis was placed on kamikaze attacks, which posed a renewed threat to all large vessels. Battleships' heavy armor and layered defenses offered some protection, but the psychological and material toll was significant. Defensive fire intensified, further straining crews and systems. As operations continued, the stakes sharpened. Battleships were now integral to invasion planning. Their absence would complicate landings. Their loss would represent a serious setback. This duality heightened sensitivity to risk and magnified the consequences of earlier modernization decisions. The engineer recognized that the ship's current performance was inseparable from choices made months earlier under pressure. Compromises accepted to meet deployment schedules now shaped operational limits. The ship functioned effectively, but margins were thinner than ideal. Every sustained action tested those margins. By the end of this phase, the battleship's return had forced both navies to confront altered realities. For the Americans, the question was how long these ships could continue to perform under escalating demands. For the Japanese, the challenge lay in countering assets they had once dismissed, now operating with renewed effectiveness. The system-level consequences of these developments were still unfolding, shaped by attrition, adaptation, and the relentless pace of operations. By early 1945, the Pacific War had narrowed in geographic scope but intensified in character. American forces advanced toward the Japanese home islands through a sequence of increasingly costly operations. Amphibious assaults were now conducted under constant threat from air attack, including organized suicide missions. Naval formations adapted accordingly, relying on layered defenses and sustained fire support. The rebuilt battleships, including West Virginia, were no longer novelties within these formations. They were established components, assigned specific roles, and expected to perform them reliably. Their employment reflected accumulated experience rather than theoretical planning. Battleships were positioned to deliver pre-landing bombardment, remain on station to support ground forces, and provide heavy anti-aircraft fire during prolonged exposure to attack. During operations such as the assault on Okinawa, these roles converged. Shore bombardment began days before landings and continued intermittently for weeks. West Virginia's main batteries fired thousands of rounds, targeting identified fortifications, cave systems, and artillery positions. The ship's engineering staff monitored wear and heat accumulation closely, adjusting firing schedules when possible to manage mechanical strain. Air defense demands were continuous. Radar operators tracked incoming aircraft amid cluttered airspace. Anti-aircraft crews maintained readiness for extended periods, often engaging targets at short notice. The integration of radar-directed fire, refined through months of operations, proved essential. While no system offered complete protection, the battleship's dense fire contributed to the overall resilience of the fleet. Damage was unavoidable. Near misses caused structural shock. Fragments and debris inflicted localized harm. Occasional direct hits tested armor and compartmentalization. In each case, damage control teams responded according to training refined through earlier experience. The ship's survival depended less on any single feature than on the cumulative effect of design, modernization, and disciplined procedure. Japanese attacks during this period reflected desperation as much as determination. Aircraft were launched with limited fuel reserves and minimal expectation of return. Tactics emphasized penetration over survivability. Against such attacks, battleships were neither invulnerable nor uniquely exposed. Their size made them visible, but their protection and defensive fire made them difficult to disable quickly. Japanese commanders, by this stage, no longer regarded American battleships as obsolete remnants. Operational reports acknowledged their persistent presence and effectiveness. Yet recognition came without practical remedy. Resource shortages, degraded training pipelines, and industrial constraints limited Japan's ability to counter them systematically. The initial dismissal of these ships, once a matter of confidence, became a historical footnote overshadowed by more immediate concerns. Within the American Navy, assessments of battleship performance matured. After-action analyses identified strengths and limitations with equal clarity. Battleships had proven valuable in roles that carriers could not fully replace. Their endurance, firepower, and damage tolerance made them uniquely suited to sustained operations near hostile shores. At the same time, their dependence on air cover and logistical support reaffirmed their subordinate position within carrier-centric strategy. For the engineer who had overseen West Virginia's recovery, the war's final months brought a sense of professional closure rather than triumph. His responsibilities remained technical and procedural, ensuring machinery readiness, documenting wear, coordinating repairs during brief maintenance windows. The ship's history, from sinking to return, was acknowledged within official records but rarely discussed in personal terms. As hostilities ended in August 1945, West Virginia and her sister ships transitioned once more. Combat operations ceased, but administrative tasks multiplied. Equipment was inspected, ammunition unloaded, and personnel reassigned. Damage accumulated over years of service was cataloged for future decision-making. The question was no longer how these ships would fight, but what role they would play in a post-war fleet. The answer emerged gradually and without ceremony. Advances in naval aviation, missile technology, and propulsion systems rendered battleships increasingly impractical as frontline units. Their wartime contributions were recognized, but strategic planning moved on. Some ships were placed in reserve, others were decommissioned after brief post-war service. Modernization beyond wartime standards was deemed unnecessary. Institutionally, the experience informed naval doctrine in understated ways. The war demonstrated that platforms dismissed as outdated could regain relevance through adaptation, but also that such relevance was situational and temporary. Flexibility in design and doctrine mattered more than adherence to pre-war categories. The rebuilt battleships became case studies rather than templates. In Japanese post-war analysis, the early assumption that American battleships had been eliminated at Pearl Harbor was revisited with critical distance. The failure lay not in the initial assessment of damage, but in the underestimation of American capacity for repair, modification, and integration. That capacity, more than any individual ship, shaped the later stages of the war. West Virginia's legacy did not center on a single decisive action. It resided in continuity, a ship damaged, restored, and employed consistently across multiple campaigns. Her return to service challenged early wartime narratives without overturning strategic realities. She did not redefine naval warfare, but she demonstrated that adaptation could extend the utility of existing assets under changing conditions. For those who worked aboard her, the experience reinforced professional lessons. Engineering decisions made under pressure carried long-term consequences. Compromises accepted for operational necessity required ongoing management. Success was measured not by dramatic moments, but by sustained functionality under stress. After decommissioning, West Virginia's story receded into archival records, veterans' accounts, and technical reports. Public memory favored carriers and aircraft, symbols more closely aligned with the war's defining images. Battleships occupied a quieter place, acknowledged but rarely emphasized, yet their presence had mattered. They had provided fire where aircraft could not linger. They had absorbed punishment that might have disabled lighter ships. They had returned, contrary to expectation, not as relics of a vanished doctrine, but as adapted instruments of a war that had outgrown them even as it relied on them. The Japanese commanders who once dismissed these ships as old had been correct in one sense. The battleships belonged to an earlier design era. What they underestimated was the extent to which new capabilities could be grafted onto old frameworks, and how long such hybrids could remain useful when circumstances demanded it. That lesson, like the ships themselves, endured quietly beyond the war's end.